We've talked at some length about how precipitation happens, why it occurs, what the physical mechanisms are, but we also need to talk about how, as hydrologists, we actually go about measuring precipitation and why we would need to do so. Well, it's really important. It's important for things like flood forecasting, a phenomenon that kills hundreds of thousands of people. It's important for predicting things like landslides, which are often triggered by intense bits of rainfall. And then fundamentally, it's important in all weather and meteorological and hydrological modeling. These models are typically driven by precipitation patterns, and they require direct observations to get accurate results. How can we go about measuring precipitation? I'm going to divide the ways in which we measure precipitation into two general categories. We can make point or aerially based measurements. And when it comes to point-based measurements, as the name implies, these are measurements that are made at a single location. And the absolute simplest method is really just to place a bucket outside and come back and periodically measure the amount of water that's fallen into it. Pour this water into a graduated cylinder, for example, figure out the area of the bucket, and you've got how much rain has fallen. This is the simplest amount. So you would divide this opening A by the depth to end up getting the amount of water that's fallen. But we can improve on this with what's known as the standard rain gauge. So this here is the bucket method. In the standard gauge method, there's an opening that then reduces via a funnel to a graduated cylinder. And the reason this is slightly better is because this opening is usually about 10 times the size of the area of this graduated part of the cylinder, but it amplifies the amount of rain that falls and enables a greater measurement precision. So you can walk right up to this and read the water level in here with a fair amount of accuracy. One of the drawbacks of these two methods are that they require manual observation. You have to physically go up and measure this whenever you want to get a reading. I'll note that these are drawbacks. And there's no real info on the intensity of rainfall as a function of time within the measurement interval that you're considering here. In contrast, there are other types of aerial-based measurements that are known as recording gauges. And these gauges are designed to overcome both of the drawbacks associated with the bucket type and the standard type gauge. The first one is known as a tipping bucket gauge, and it has the same kind of entrance funnel as the standard gauge, so it's collecting precipitation, it's funneling it down. But then down here, instead of there being a graduated cylinder, there are these two little buckets that are kind of inclined. And there's a pivot point right here. And there's usually a little magnet right here. And the idea is that water flows down into this bucket, it fills it up to a set amount, and then the weight on this side causes the whole bucket to tip, and the water pours out. And we've specially calibrated the amount of water that's required to fill and tip this bucket in relation to how the area of the cylinder. So we know, for example, each tip is equal to 0.2 millimeters of rainfall. And the magnet here, as it goes back and forth, enables an electromagnetic reader to record the tips through time. So you don't even have to be here. You can electronically record the number of tips that this thing goes back and forth through time. And that tells you how much rain fell, as well as the relative intensity, down to at least the volume that's within this bucket. Another type of recording gauge similarly funnels water down, but then it falls into some sort of a cylinder that's sitting on a scale. And so this measures the weight. So this is a weighing gauge. And so this is continuously recording the weight, and as the weight of water increases, the weight increases, and you can record that through time to get an estimate of the intensities and the total amount. With this one, you need to figure out some way to empty this periodically, and there are a variety of ways to do that. I'll note that this is the tipping bucket gauge.